Alright guys, this is going to be the first video for Unit 10. This is going to be talking about solution chemistry, so a lot of water, a lot of things that mix, a lot of things that you're kind of familiar with. We're going to go into a lot more detail with it. Let's go ahead and start. Hope you noticed by now that you've got a lot more space in your notes. You should be working on how to write these things in your own words. You have to write down every word. It's a good idea, but just do what you got to do. So the first part, properties of water. You have several properties here. You're going to have 5 of them. The first one of those is hydrogen bonding. Now, water is polar. That's something you definitely didn't know. We can talk more about what polar means in class. It just means that the electrons are unevenly distributed and cause partial positive and partial negative reactions within molecules. So if we look at this water molecule right here, this is H2O. Remember that big red dot? That is the oxygen. Whereas the... well, these are backwards. Well, the charges are backwards, that's okay. The 2 little hydrogens sitting there up top. Now if we think about it, if we draw it right, remember it looks like that. Oxygen is a -2 charge, and each hydrogen is a little bitty +1. So already we can see that one side, the oxygen side, is highly negative, whereas the hydrogen side is highly positive. Also, if you look at the mass of an oxygen, it's 16, versus the mass of a hydrogen, it's 1. So that -2 charge is actually 32 times bigger than each individual hydrogen charge. So we have a size distribution and an electron distribution that makes it polar. You definitely don't need to know that entire explanation, but it's good to know. Water molecules are formed in groups of 5 molecules because of hydrogen bonding. That's just the maximum that the electrons will allow. And hydrogen bonds are really just between a positive and a negative charge. So there's not an actual physical bond here. It's just an electrostatic interaction. It's not quite an ionic bond though. But it's just you have a positive charge and your negative charge, and they kind of connect. Remember, this is happening millions, if not billions of times within a cup of water. So even though these are very small and weak charges, you have a million or a billion of them, they make a substantial contribution to it. Next part, surface tension and cohesion. Cohesion is the attraction between substances of the same kind. Think about co-worker. We're the same kind of worker. We work together. So that's going to be the same kind. You'll get to adhesion later, which can be different things. Water molecules are attracted to each other because they are polar. You'll find out this is a common theme. Polar likes to be with polar. Polar dissolves polar. They're kind of cliquey like that. They like to stay with their polar buddies. The cohesion of water molecule causes surface tension. If you look over here, that little guy walking in the water, that's why he's not falling through the water, because those hydrogen bonds are causing surface tension, which allows the water to not break when something immediately gets into it. You've experienced surface tension before when you belly flop into a pool. That's why it hurts so bad. You've got to break the initial force of the water with your belly before you actually go into it. And it's that force of the water pushing back, that surface tension pushing back, that's caused that big red belly on you when you get out of the pool. And surface tension prevents the surface. That's what I just talked about. And then down here in the bottom right, you see a good picture of surface tension. You see how these water molecules are aligned, and you can see that there's a hydrogen bond there, hydrogen bond there. And so it makes a very substantial force when you're trying to break water. Okay, the third one, adhesion. Remember, adhesion is opposite of cohesion. Cohesion is the attraction between same substances, while adhesion is the attraction between different substances. Water molecules attracted to other polar substances. This is actually known as capillary action, which if you're going into nursing school, you'll need to know a lot about capillary action and be familiar with those capillary tubes. But when that happens, it means that water is more likely to bond and to be attracted to the container rather than itself. For some reason, or for one reason or another, it wants to be with something else other than itself. So cohesion causes the water to stick together to form drops. Surface tension causes those drops not to break and stay round, and adhesion keeps them in one place. And that's what this little picture is showing you down here. Density in solid states. This one's important because water is going to have a very different density in a solid and a liquid state. But as the temperature decreases, the forming of hydrogen bonds creates a crystalline structure which is very open, which means it forms pockets, is what that's talking about. And because it's forming those pockets, and those pockets are filled with air, it actually lowers the density of water, because instead of having a bunch of water molecules crammed together, now we've got a couple molecules with air between them, and that lowers the mass of it. And then the empty space between the molecules lowers the overall mass for the given volume, blah, 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 blah. What this means, I don't know why it's not here, but the solid form is less dense. So cohesion. Remember, co-worker means the same kind of worker. Which state of water has the greatest density and why? It's solid because of those air pockets. Those air pockets form because those hydrogen bonds can get closer and closer together. And describe the property of water that allows fish to survive through severe winters. And that's going to be density, very much like the last problem. If the ice were to freeze and sink to the bottom, that would squish all the fish. So it would squish all the fish and would suffocate them with no oxygen for them to breathe. With ice going to the top, they can still have oxygen permeating into the water that allows fish to breathe instead of squishing them and freezing them in place all winter long. That would be that.